How to do these, so let's look at it and see if we can get it sorted out. It says cosine of 8 pi over 3. So the first thing we probably want to do with the cosine of 8 pi over 3 is what? What's probably the first thing you're going to want to do?
Divide 180 by 3.
Change that radian measure into a degree measure, right? Okay, so here we go. We know that pi is
180.
180 divided by 3 is 60 times 8.
120.
Okay, let's start over again. Pi is
180.
divided by 3
60,
times 8.
48.
480. So we have the cosine of 480 degrees. But 480 degrees is more than a revolution, right? So we don't need all that extra spinning. So if we take out the extra spin, this is really just how big of an angle? 120. So we're going to draw a picture of a 120 degree angle. So again, in standard position, always starting here. Here would be 120 degrees. Drop my perpendicular down. How big is my reference angle? That's this little angle right here. That's 60. I know across from the 60 is the root 3. So there are the sides of the triangle. Anything in there negative?
-1.
The 1 has to be negative. Your x value is negative. You're sitting in quadrant 2. You're going left. So your x quadrant, or your x coordinate is negative. Your y is positive, and your r is always positive. Now, we want the cosine. Cosine is either adjacent over hypotenuse or x over r. Either way you do it, the answer is -1/2. Right? Anna?
Can you do 8?
What's 8?
Oh, tan of a -240.
Actually, that picture's going to be exactly the same, because if I draw -240, that's this way, right? -240. How big is that reference angle?
60.
That's 60. It's exactly the same triangle, isn't it?
I just didn't know if you would drop it the other way or not, but you can't drop it that way.
No, you can't drop it that way. Remember, that makes me twitch.
Yeah.
Never, ever, ever will you draw a triangle that doesn't look like this. All the triangles will look like that. Always, always, always. So the tangent here would be -√3. Because x is -1, y is √3, r is 2. Tangent is opposite over adjacent or y over x. Either way you do it, it's -√3. Anna, did you have a question? No. Now, if you would, look quickly at the back of the first page of your big packet. The back of the first page. This was a quiz given last year, it looks like. Sine 120. Here we go. Oh, wait a minute. 120 I already have drawn. I'm not going to redraw it. I have 120 already drawn from that other problem. What's the sine of 120? 3/2. So the answer to the sine of 120 would be √3/2. I'm not going to redraw that picture. I've already drawn it twice. This is a 120 degree angle. The sine is y over r, or opposite over hypotenuse. How about cosine 5 pi over 4? Well, what's pi?
180.
Divided by 4
45.
times 5.
225.
So we're looking for the cosine at 225. 225 is not the answer. We're looking for the cosine of 225. 25. So, where will 225 be? Which quadrant? Down here in the third quadrant. Remember, halfway around's 180. How big's my reference angle then? That's this little angle inside the triangle right here at the origin. That would be 45. Which means the sides of the triangle are 1 root 2. Anything negative in that picture? What's negative? Both of the ones are negative, aren't they this time? Because we're going left and down. In quadrant 3, your x is negative and your y is negative, and of course your r is always positive. Now we want the cosine. What's the cosine? X over r, or adjacent over hypotenuse. Any way you look at it, you get negative 1 over root 2, which we rationalize as negative root 2 over 2. The other quiz had tan 180. Where's 180? Ooh, it's what we call a quadrantal angle. It's right here, isn't it?
Yeah.
Now you need to know the coordinates of that point. You can't find the coordinates of that point unless you know what the radius of the circle is. So you get to pick your own radius. I like 1, but does it matter? No. You can use whatever number you want. You can use 6 if you want, sure. But you can use 1/2 if you want, but that's up to you. I'm going to use 1. If I let my radius be 1, what will the coordinates of that point be? Negative 1, 0. So I have x equal to 1, negative 1, excuse me, y equal to 0, and r is 1. I need the tangent. What's the definition of the tangent? Y over x. 0 over negative 1 is 0. That's how we handle quadrantal angles. The angles who terminate on an axis. They're actually on an axis. One more. Cosine 5 pi over 6. Let's change it to degrees. What's pi? Divided by 6. Times 5. This is the cosine of 150. Which quadrant is 150 in? It is in quadrant 2. How big is my reference angle? 30, which means this is 1, this is root 3, and this is 2. Anything negative?
Negative root 3.
Okay, only one thing is negative. Which one is it?
Negative root 3.
This is negative. Why is that negative?
Because it goes over to the...
We're going left, right? So x is negative root 3, y is 1, and r is 2. What's cosine? X over r, so negative root 3 over 2, or adjacent over hypotenuse, if you want to look at your triangle and do it that way. Now yesterday, in one of the classes, we went through a bunch of these, just like we did with you yesterday, and one of the kids said, Miss Ford, the answers are always like the same. They're always root 3s. And stuff. Well, yes, they are, because why? All our triangles are or 45, 45, 90. So you're going to get some combination of those numbers over and over again. Okay, now the logical question that should come up is, well, Mrs. Ford, what do I do if it's not a 30, 60, 90 triangle? What if, for some reason, I am doing a problem and I need to know the tangent of 58 degrees? Now, I could draw 58 degrees. There's absolutely no problem drawing that. The problem is what?
You have to do how to calculate
Well, I don't know what these sides would be, right? Because the only sides I know are the 30, 60, 90, and 45, 45, 90. So we're going to use our calculators to do that. It is simple. I don't want to make this an issue. You press tangent 58. However, you do have to make sure that your calculator is in degree mode. This will cause you great grief. If you're not in the correct mode, all of your answers will be wrong, even if you press the right buttons. So go to mode in the top line, and do you see how one of your options is radians and degrees? If you're doing a degree problem, make sure you got degrees highlighted. If you're doing a radian problem, and we'll do one in a minute, then you want to have radian highlighted. Okay, so you got degree highlighted. We'll press tangent 58, and the answer is about 1.6. Agreed? Now, another thing you have to be careful of is, what if the question is, find the cotangent of 58 degrees? Now wait a minute. You paid $100 for this calculator and it does not have a cotangent button. What do we do?
Second, put it to the negative.
No. No. What is the definition of the cotangent? Reciprocal of tangent. So you physically type in 1 divided by tangent 58. Please do not press second tangent. That is a whole nother ball game that we'll talk about. It is not the cotangent. The only way to enter a cotangent into your calculator is using the definition 1 divided by tangent. So 1 divided by tan 58.624 something, right? Likewise, if we want the secant of 19 degrees 12 minutes, you do not have a secant button. There is no button you can press that will give you a secant. You have to use the definition. What's the definition of the secant? 1 divided by cosine. Now you can say hypotenuse over adjacent, and I would agree that's a definition of the secant, but I don't have a hypotenuse and adjacent button either. I gotta use the buttons on my calculator. Okay, so I'm doing 1 divided by cosine. Now do you remember how to put in 19 degrees 12 minutes? 19, go in the angle, get your degree mark. 12, go in the angle, get your minute mark. And the answer to this question is 1.0589, if I round it off. Now what if we wanted to find the cosecant, let's not do cosecant, let's do a sine of 3 pi over 7. Now, could you change 3 pi over 7 into degrees? Sure you could, but we don't need to do that. We can enter this into our calculator, go to mode, put it in radians, and then literally type sine 3 pi divided by 7. 3 pi divided by 7. Just key that in, press enter, and it's 0.9749.
Wait, when do you close the parentheses? After the 7?
So the fraction needs to be in parentheses. So if we wanted the cosecant of 3 pi, or let's not do 3 again, 7 pi over 17, we wanted the cosecant of that, How am I gonna get a cosecant in my calculator? 1 divided by sine, and then 7 pi divided by 17. And the answer to that one is 1.0397.
When you're using pi, is that the only time you'll put it into radians? Your
No,
calculator?
you could find the tangent of 2, that would be the tangent of 2 radians. The only time if there's no degree mark, it's a radian measure. If there's no degree mark, it's a radian measure.
I keep getting, for the first one, I keep getting like 0.023.
Yeah. For this one,
Yeah.
sine 3 pi divided by 7. I don't know what you're doing
I'm
wrong.
getting the same thing radius.
Did you
Yes,
change it
ma'am.
into radians?
Yeah.
You have to go to mode and change it into radians. If you're not in the right mode, you can press all the right buttons, but you won't get the right answer. You've got to tell the calculator what mode you want it to interpret that angle in. So tonight, there's a few calculator problems in your book. You'll get a little practice on that. A couple other kinds of problems you're going to get to do tonight. Let's take a look at this. The directions, they took this straight out of the book. They draw a triangle like this and they say find the value of all of the trig functions, all 6 of them. Find the value of all 6 trig functions. Now, of course, order doesn't matter, but when I do it, I always line them up with their reciprocals. So I've got sine and cosecant, cosine and secant, tangent and cotangent. This is a Greek letter theta. Trigonometry was a branch of mathematics developed by the Greeks, or at least studied a lot by the Greeks. And so we use Greek letters often for the angles. That's a theta. No big deal. It's like an x. You can use x if you want. Doesn't matter. So we need to find the values of all these functions. This is a right triangle. So I am going to think about SOHCAHTOA. Might write it down on my paper. Before I can start, though, there appears to be something missing, doesn't there? What's missing here? This side? I'm going to need that to answer the questions. So how might I find that side? This is a right triangle. So I can say x squared plus 36 equals 64. Would you agree with that? So x squared equals 28, and x equals the square root of 28, which is 2 root 7. So now I got all 3 sides. So now I can start answering the questions. Now, this is theta. So what's this side?
Opposite.
This is the opposite side. This is the adjacent side, and this, of course, is the hypotenuse. What's opposite and adjacent depends on where your angle is, right? So pay attention. This is the angle we're doing. So this is the opposite, and this is the adjacent. So what's my sine value? What's sine? So that would be 6/8 3/4, which immediately means the cosecant is 4/3. What's my cosine? So 2 root 7 over 8, or root 7 over 4. Meaning the secant then is 4 over root 7, or 4 root 7 over 7. What's my tangent? 6 over 2 root 7, which reduces to 3 over root 7, which reduces to 3 root 7 over 7. And then for my cotangent, I'm not gonna flip that one, I'm gonna flip this one. Because that makes my cotangent root 7 over 3. That's pretty easy, isn't it?
Do we have to put this in or no?
What?
Do we have to plug it in, like?
What do you mean plug it in?
Like in our calculators?
No, the direction said, find the value of the 6 trig functions, we're done, did that. There is another set of problems that are really exactly the same as this, but they don't draw a picture. Instead, they say something like, the secant of theta is 17/5. Find all of the other functions. So find the sine, and the cosine, and the tangent, and the cosecant, and the secant we already know. That one they gave us, and the cotangent. So there's no picture, they just say, okay, the secant of some angle is 17/5. Find all the other functions. Well, this is a no-brainer. If the secant is 17/5, what do you know about cosine? It's 5 over 17, so that's a gimme. Now, any idea how we might find the rest of them, though? Could we draw a triangle? Absolutely, we could draw a right triangle. And if that's theta, you can put theta wherever you want. I'll put it right there just so that's just like what I did a minute ago. If I know the cosine is 5/17, tell me about the sides of this triangle. If I know the cosine is 5/17, this is 5, and this is 17. So aren't we right back to where we were over here? We'll use the Pythagorean theorem. 25 plus y squared equals 289, I think.
Yeah.
So y squared equals, what is that?
264.
264. That's not a square, is it?
No.
Shooty tooty. So the square root of 264. 4 times 66, just 2 times 2 times 2 times 3 times 11. So I guess it's 2 root 66. Would you agree with that? So then we can fill in the rest. So your sine is 2 root 66 over 17. Would you agree with that? Remember, here's theta. Your cosecant then, naturally I don't have enough room. Your cosecant is an S. It'll be 17 over 2 root 66, which is 17 root 66 over 132. Yuck. And our tangent is 2 root 66 over 5. So the cotangent is 5 over 2 root 66, or 5 root 66 over 132. Easy, a lot of arithmetic, but easy, right? Okay. Now, tomorrow we're going to have a quiz, and it's going to be kind of a combination quiz. Kind of a combination of the one I turned back, that some of you did absolutely great on, and some of you still have a little bit of stuff to learn in terms of memorization. So there's some stuff like that, and then I'll throw in a question or two, like find the cosine of 300 degrees. Okay, We did this last night on that worksheet. We just practiced a few of them here. We're gonna do one more right now. We're gonna find the cosine of 300. What do I do to find the cosine of 300? No calculator. So I draw my circle. And I figure out where 300 is. And I start here. It's positive, so I go up and around and around and around and around to about here.
Yeah.
Remember, this is 270. If this is 300, then how big is my reference angle right here inside the triangle? 60. So this is root 3, and this is 1, and this is 2. You should be able to do that automatically. Anything negative in that picture? The root 3 is negative. Remember, you lose half credit if you don't have a negative. If you don't have the right sign, you lose half credit. It's really important. What do I want, the cosine? What's the answer? Cosine would be what? 1/2. X over R, adjacent over hypotenuse. So everybody clear on the expectation for a little quiz tomorrow? Won't be a huge thing, small quiz. Okay. Now, I'm going to stretch you a little bit. And then we'll look at your other homework questions if you have any about those book problems. But here's what I want you to do. Suppose I tell you that the cosine of the angle is root 3 over 2. Could you tell me what the angle is? Let's think about this for a minute. Maggie?
Would you draw a triangle and then put a theta in one of the theta?
I'm gonna go ahead, I'm gonna draw my circle. And I'm gonna go ahead, Maggie, and just for the fun of it, I'm gonna draw in all 4 triangles, okay? And then I'm gonna narrow it down, because the answer isn't gonna be all 4 of those triangles. I need the cosine to be a positive root 3 over 2. Now, if this is my angle right here, remember, these are our thetas right in here. Where would the root 3 and the 2 go?
The root 3 would be the adjacent, so it'd be on the lines.
So this would be root 3, and this would be 2?
Yeah.
Would you agree with that? And this would be 2, this would be 2, and this would be root 3, and this would be 2. In this triangle, this would be the root 3 and the 2. But wait a minute. In this triangle, would that be a root 3? It'd be a negative root 3, wouldn't it? So this triangle and this triangle won't work. They won't give me the positive root 3 over 2. Would you agree with that? Now, if that's a root 3 and that's a 2, what's this side going to be? That's going to be a 1. And what angle is always across from the 1 in a 1, 2, root 3 triangle? What angle is across from the 1? That's a 30. So these angles, these reference angles, are 30 degrees. So what's the answer to the question? What angles, there's 2 of them, what angles will have a cosine of root 3 over 2? This one, which is 30, and there's another one, this one, which would be 330. Now, if you followed that, you are awesome, because that's a little bit tricky. We're going to spend some more time on that for sure. But if you followed that, if that kind of made sense to you, you are doing very, very well. Let's do one more. And then we'll look at your other homework questions. Suppose I told you that the sine was negative 1/2. And your job is to tell me what theta is. What angle has a sine of negative 1/2. Well, think about it for a second. Can we rule out any of our bow ties here? Can we rule any of those out if the sine is a negative 1/2? Which ones can be ruled out? This one, we know it can't be there because x and y are both positive there, right?
Yeah.
Okay.
It can't be 3 quadrant.
Why
Can't
not?
be what? Because it has to be both negative.
Both negatives make a positive.
Okay, now wait a minute. What's sine? What's the definition of sine?
Over hypotenuse.
Okay, or
Y over.
y over r. Now, what do you know about r? It is always positive. So doesn't this mean y has to be negative?
Yeah.
Okay, so where is y negative?
It can't be quadrant 2.
It can't be quadrant 2. Is y negative here?
Yeah.
Is y negative here? These are where your answers are, okay? So you've got a situation where the y is negative 1 and the radius is 2. Look at this triangle right here. If that's a negative 1 and that's a 2, what's this? A negative root 3. What's the measure of this angle right here? 30, because it's across from the 1. Is 30 the answer to the question then? No. 30 is the reference angle. This is the answer to the question, right? Remember, you gotta start over here. So what's the answer to the question? 210. The other answer to the question is all the way around to here, which is 330. Take your calculator out. Let's go back to this problem right here for a minute. Would you type in, you wanted to use this button before and I wouldn't let you. Would you type this in to your calculator? Make sure you're in degrees. Put your calculator back in degrees. And type this in. Tell me what it says. You have a button. Press your second cosine button. Please tell me it said 30. Got to set in degrees. Go to mode, put it in degrees, and then type this right here, and it'll say 30.
What did we put in radian?
What?
Radian. What did we put in radian?
When radians, when you are finding like anything, when your angle is in radians, if you want the angle in radians. I could get this angle in radians, but I did the problem in degrees, so I wanted you to see what you just did. You just found the angle whose cosine is root 3 over 2. When you press this button, kids, you are finding an angle. You only use this button when your job is to find an angle. So could I have done this problem on my calculator? Halfway, because how many answers did we get? How many did the calculator give you? 1. So you can use the calculator to kind of help you, but it will never give you the total answer because it only gives you 1, and these problems always have 2 answers, at least. Okay? All right. Well, we'll talk more about that tomorrow. You know what we need to do for tomorrow. Did anybody have a question about a problem from the book last time? I gave you 3 problems in the book to do, as well as your worksheet. Anybody have a problem with one of the problems in the book? Okay, well then you've got, what, 3 minutes or so? You can get started on your homework.